Hello, very good evening, everyone. Hope you are very well. So, today, as you know, we are going to study about we are going to see some practice questions which we have been covered or which we have seen in NEET examination previously. So, today's topic is NCRT Chapter 1 Solutions NEET PYQs. Let's start. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. Okay, so let's start with our first question, which is a MCQ question which has been taken from the NCRT section 1.3 under 1.3.1. So the question says that on dissolving sugar in water at room temperature, the solution feels cool to touch. Under which of the following cases dissolution of sugar will be most rapid? Okay, so we have given a condition or a situation where we are dissolving the sugar in the water at room temperature. The solution starts to feel cool to touch. Under which of the following cases in the given options the dissolution of sugar will be most rapid? You have to tell. And the given four options are sugar crystals in cold water, sugar crystals in hot water, powdered sugar in cold water, or powdered sugar in hot water. So you have some time, just analyze this question and try to solve it. Then we will see what will be its correct answer. Okay, let's see. So for this given question, the correct answer is option D, which is powdered sugar in hot water. So let's see how. And the dissolution process of sugar in the water will be most rapid when the powdered sugar means the sugar crystal are in powdered form. We crushed the sugar crystals in the powder form. When you dissolve them in the hot water, the process of dissolution of sugar in the water will happen. Why? Because in the powdered form, the surface area will decrease for the sugar and it can easily insert in the vacancies of water particle for the greater solubility or dissolution. Powdered sugar has a larger surface area compared to the granulated or crystalline sugar, allowing more sugar particles to come into contact with the water at the same time to help them dissolve in the water. And also, the dissolution of sugar in the water is an endothermic process which occurs or which is favorable at high temperature. Okay, so these are the conditions which satisfy our correct option as D option, which is powdered sugar in the hot water. Hence, D option is the correct answer. Moving on to our next question. Okay, so this question is a MCQ question. We have been taken from the NCRT section or subsection 1.3.1. The question says that at equilibrium, the rate of dissolution of a solid solute in a volatile liquid solvent is. So you have to select the correct option, which complete the sentence that at the equilibrium, rate of dissolution of solid solute in volatile liquid solvent is what? Okay, so the options are less than the rate of crystallization, greater than the rate of crystallization, equal to the rate of crystallization, or zero. So you have some time, go through it, try to solve it, and then we will see what will be the correct answer. Let's see. So for this given question, the correct answer is option C, equal to the rate of crystallization. So let's see how. Let's explain. Now, at the equilibrium condition, the rate of dissolution of a solid solute in a volatile liquid solvent. Okay, so first of all, we are using solute term and solvent term. You have to understand the meanings. Solute is always lesser than the solvent because solute is one which we are dissolving in the solvent, which makes, and they both are making a solution. Okay, so when you, the rate of dissolution of a solid solute, when you dissolve a solid solute in a volatile liquid solvent, the rate of dissolution is equal to the rate of crystallization or rate of precipitation of that particular solute. So, rate of dissolution is equal to rate of crystallization. That means by the rate the solute will dissolve is equal to the rate it will crystallize or precipitate. This means the amount of solute dissolving per unit time is exactly balanced by the amount of solute which is coming out of a solution, right? After the crystallization per unit time. As a result, the concentration of dissolved solute remains constant at equilibrium. And due to this, what will happen? The concentration of our dissolved solute will remain constant at the equilibrium. Okay, which makes the rate of dissolution and the rate of crystallization equal. And thus, the correct answer is option C. Moving on to our next question. Okay, this is a question we have taken from the NCRT section 1.3.1. The question says that a beaker contains a solution of substance A. Precipitation of substance A takes place when small amount of A is added to the solution. The solution is. So we are given a condition again in which we have a beaker which is containing a solution of a substance named A. Precipitation of substance takes place. Precipitation of substance A takes place when a small amount of A, that means we have a solution of substance A already prepared. But when you add small amount of A to the solution, the precipitation of A happens. The solution is. So what you will call that type of solution? The options are saturated, supersaturated, unsaturated, or concentrated. Okay, so you have to tell the condition or the type of or the nature of solution as per the given condition, that the beaker having a solution of a particular substance named A. When you add a small amount of A in that solution, the precipitation of A starts taking place. What you call that solution is. So you have some time, think about this question, and then we will see what will be its correct answer. Okay, so let's see. So for this given question, the correct answer is option B, super saturated solution. Now, when the solute is the smaller quantity one, solute gets precipitated in the solution, then the solution is known as super saturated solution. That means like when solute starts precipitated, the solution becomes super saturated. That means it will be, the solution is more than the saturated solution. Okay, so the super saturated solution contains more dissolved solute than it can normally hold at that temperature. That's why it starts to precipitate, right? That a supersaturated solution forms when the limit which the solution has to dissolve any solute in it has reached, and no more extra solute you can dissolve or you can add into the solution. then the solute will starts to precipitate or crystallize. Now the term we use for that kind of solution is supersaturated solution. Okay, so at that particular temperature, the solution can only hold a particular or a limit of solute, and then if you add a more solute into it, it will starts to precipitate. That solution is supersaturated solution. It is in a metastable state, so adding a small amount of solute causes excess solute to crystallize, precipitate out rapidly. Okay, so it is already in a metastable state, like saturated state. So if you add a small amount of solute, okay, that means even a small amount of solute, or you disturb the solution, it will cause the excess solute to crystallize, to precipitate out rapidly, because it can't dissolve any more solute into it, right? The limit has reached, saturation has reached. So if you add a small, even a small more amount of solute, it will starts to crystallize, and that is considered as supersaturated solution. Okay, so the term supersaturated, that's why we are using here, because in the question it is given that when you add a little amount of A, the substance A will start to precipitate. Okay, so that precipitated solute is present in the solution. That solution is supersaturated solution because it reached its maximum dissolving power of its solute. Okay, so the correct answer is option B, that is supersaturated. Okay, so moving on to the next one. This question is again an MCQ question we have taken from NCERT subsection 1.3.2. The question says that low concentration of the oxygen in the blood and tissues of pupil living at high altitude is due to what? Okay, is due to which reason? So the people who are living at higher altitudes, like on mountains or in the hilly areas, they have low concentration of oxygen in their blood and the tissues. What is the reason behind that? You have to tell. So the options are low temperature, low atmospheric pressure, high atmospheric pressure, or both low temperature and high atmospheric pressure together. So you have some time, go through it, and then we will continue to the correct answer. Okay, so let's see. So for this given question, the correct answer is option B, which is low atmospheric pressure. So at higher altitudes, the atmospheric pressure, the pressure which present above our atmosphere, is thus or you can also say it is a partial pressure of oxygen. It is actually at the higher altitude is lower than at the sea level. Okay, so at the higher altitudes, there is a difference between the partial pressure of oxygen at the sea level and the higher altitude, and this is the reason. This means that less oxygen is available to dissolve in the blood according to the Henry's law, right? Which states that the amount of gas dissolved in a liquid is proportional to its partial pressure. If the pressure of any type of gas or the partial pressure of any gas is low, that means the dissolving capacity of that gas is also low in a liquid, right? So following the Henry's law, the less oxygen is available at the higher altitude to dissolve in the blood. As a result, the people living at higher altitudes have low concentration of oxygen dissolved in their blood and tissues. Okay, so the main reason is the low atmospheric pressure present at the higher altitudes. So the correct answer is option B. Okay. Okay. Let's move on to the next one. Okay. So this question is an MCQ question, and we have taken this from NCRT section 1.6. The question says that colligative properties depend on. So you have to tell that on which of the following factors given in the options the colligative property will depend. The four options given are the nature of the solute particles dissolved in the solution, the number of solute particles in the solution, the physical properties of the solute particles dissolved in the solution, or the nature of solvent particles. Okay, solvent, solute. Okay, try to understand or relate these terms. Solute is the lesser amount thing present in the solution which you use to dissolve in the solvent to make the solution. Okay, so you have some time, go through it, try to come out at its correct answer, and then we will see what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option B, which is the number of solute particles present in the solution. So let's see how. So colligative properties depend on the number of solute particles which are present in a solution and not on the nature or the identity of the solute particles. Okay, solute particles, that means the particles or the smaller amount of solute or the smaller amount of particles which are dissolving in a particular solvent to make the solution. Okay, so colligative properties are depending on number of solute particle and not on its nature, whether they are dissolvable, acidic, basic, not on their nature and not on their identity. Okay, so if you define the the colligative properties include various terms like relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, osmotic pressure. All these properties you see, which comes under the colligative properties, depend only on the quantity, number of solute particles. Solute particles either include molecules or ions in a given amount of solvent, irrespective of what those particles are and how their nature is. Okay, so colligative properties depend upon the number of solute particles present in the solution, and hence the correct answer is option B. Okay. Okay, let's move on to the next one. Okay, this is a question which is MCQ type question, and this has been from NCRT subsection 1.6.4. The question says that at a given temperature, osmotic pressure of a concentrated solution of a substance. Okay, so after this, you have to choose the correct option which can complete or which can correctly fit in the question statement given. So we have given in the question that at a given temperature, the osmotic pressure of a concentrated solution, okay, of a concentrated solution of substance, the options are is higher than that of dilute solution, is lower than that of dilute solution, it gains water due to reverse osmosis, or it loses water due to osmosis. Okay, you have to pick a statement which can correctly complete the statement which is given in our question already. Okay, so think here about the osmotic pressure, the reverse osmosis, the concentrated solution or the dilute solution. What is the relation? Why we are giving importance to this term dilute and concentrated here? Okay. So you have some time, go through it, think about it, and then we will see what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option A, that it is higher, or you can complete it like at a given temperature, osmotic pressure of a concentrated solution of substance is higher than that of dilute solution. Now let's see what will be its explanation. So osmotic pressure is defined as pi is equals to CRT. Okay, we represent the osmotic pressure by this term pi, which we generally use in the mathematics, right? So pi is equals to CRT. Here in the chemistry, pi represents for osmotic pressure, C is for the concentration, R is for the gas constant, and T is for the temperature. So this equation pi equals to CRT is a NCRT formula number 1.39 given in the solutions chapter in the textbook. Now here C is a molar concentration of the solution, R is a gas constant, and T is the absolute temperature. And pi I already said it is a osmotic pressure. Now for a concentrated solution, the C, which is defined as molar concentration, the C will be higher. That means C has higher value than the dilute solution, as the name says, concentrated, right? So the for the concentrated solution, C value, that means this C value will be higher than the dilute solution. If you compare from the dilute solution, dilute means the water quantity or the solvent quantity is more. The concentrated solution means the solute quantity is more than the solvent, okay, or than the water. Hence, as the concentration, that is C, increases, the osmotic pressure increases proportionally. You can depict this from the given formula of osmotic pressure. The pi is equals to CRT. R is a constant. T you can also consider as constant because already in the question it is mentioned at a given temperature. That means temperature is not going to change. It is going to be a particular number, or a particular temperature at which we are talking about this condition. So pi is directly depending or proportionally depending on the concentration only, right? Because R is a constant, T is already a constant as per the question. So pi is directly proportional to the C, that means concentration. So if the concentration C is increased, pi will also increase. So that is why we have the correct answer as option A, that at a given temperature, osmotic pressure of concentrated solution is higher than that of dilute solution. Okay, so the option A will be the correct answer. Okay, okay, moving on to our next question. Okay, so this question is again a MCQ question, and it has been from NCRT subsection 1.6.4. The question says that the plot of osmotic pressure, which is pi, versus concentration, which whose unit is mole per liter, for a solution gives a straight line with the slope 25.73 liter bar per mole. The temperature at which the osmotic pressure measurement is done is. So first of all, in this question, what we have to tell? We have to tell the temperature. Which temperature? At which you will, you can say, measure the osmotic pressure. Okay, the given value is of R, which is a gas constant, and you can use the R as 0.083 liter bar per mole per Kelvin in this question while solving this question. Okay, so what is the information given? That we have a plot, that means we have a graph of osmotic pressure versus concentration, or you can say molarity, for a solution which gives a straight line. So the graph is a straight line Okay, the graph is a straight line and the slope of the graph is also given. The value of the slope is also given, which is 25.73. You have to tell the temperature at which the osmotic pressure measurement is done. The four options given are 37 degrees Celsius, 310 degrees Celsius, 25.73 degrees Celsius, or 12.05 degree Celsius. So these are the four temperature given in the degree Celsius. Okay, don't forget, given in the degree Celsius. So you have to tell that which is the temperature at which we will measure the osmotic pressure. And you have some time, go through it, try to solve it, and then we will see that what will be the value of temperature finally and what will be the answer for this question. Okay. Okay, let's see. So for this given question, the correct answer is option A, which is 37 degrees Celsius. Okay, now let's see how. So first of all, osmotic pressure is given as pi is equals to CRT, right? We have already discussed this. And we have taken this equation from the NCRT formula 1.39 in the solutions chapter from the textbook. Now, when you plot pi against C, that means when you draw graph between the pi, that means the osmotic pressure, and the concentration, pi on the y-axis and the concentration on the x-axis, you will get a straight line. It is already given, right? So slope will be equals to RT, the constant term RT. Okay, so slope will be equals to RT, and RT value is already given, which is 25.73 liter bar mole inverse, right? So slope will be RT, which is equals to 25.73 liter bar mole inverse. This value is already given in our question, right? Now, what we will do, first of all, R is a gas constant. Okay, you can use R as this much already given in the question. T, we don't know, right? And T is the term which we have to find out, right? This RT is we used or we have taken it from the osmotic pressure formula pi equals to CRT. And for the osmotic pressure measurement, you have to identify the temperature. So as we are doing, so T will be 25.73 divided by R. Okay, we just rearrange this equation. RT is equals to this much and T will be equals to 25.73 by R. Now R you can put it as 0.083. So it will be 25.73 liter bar mole inverse upon 0.083 liter bar mole inverse Kelvin inverse. Now you have to divide these two terms. That means you have to solve for this fraction, and the unit will also get cancelled out, and only remaining unit will be Kelvin inverse in the denominator, which will go in the numerator as Kelvin, as the unit of temperature. So after solving this fraction, the temperature is coming out as 310 Kelvin. But remember, our questions are given in, our options are given in degree Celsius unit, right? So this is a trick I want to mention, that many of the examinations, what the persons do, that students do, they ignore what are the formulas. They just focus on the numbers, not the units. Okay, and if let's suppose here one of the option is 310 degrees Celsius, right? You don't in the that you have to solve the paper in very quick, you have lesser time, so you just mark that 310 degrees Celsius as the correct answer, but that will be the wrong. Okay, so try that you focus on that what will be the unit of the options given, what your answer is coming into. Okay, so 310 Kelvin will be the temperature which we will use to measure the osmotic pressure. But the options, as our options are given in degree Celsius, so you have to convert this Kelvin into the degree Celsius. How? Just by subtracting 273 from this Kelvin temperature, and it will be equals to 37 degree Celsius. Okay, so this is an important thing. Just try to remember that don't solve the question in hurry, that your answer is correct but you mark the incorrect. No one going to see your calculations. Only you will be getting the marks on the basis of the option you have marked, right? So remember these small things. Even this happen in the questions also, that the student in a hurry will not read the question properly, and in hurry he or she will mark any question or any option as the correct one, but that will not be the correct. Okay, and he or she will lose the mark there. So okay, so for this question the correct answer is option A, which is 37 degree Celsius. Okay, let's move on to the next question. Okay, so this is a question. This is a MCQ type question, and we have taken this from NCRT section 1.4. The question says that the correct option for the value of vapor pressure of a solution at 45 degrees Celsius with benzene to octane in the molar ratio 3:2 is. So you have to tell from the options that which is the correct option for the value of vapor pressure of a solution at this temperature 45 degrees Celsius with benzene to the octane in the molar ratio 3:2. So benzene to octane ratio is given for a solution which is 3:2. You have to tell the vapor pressure of the solution. Okay. And the information given as that at 45 degrees Celsius, the vapor pressure of benzene is 280 millimeter of Hg, mm of Hg, and that of octane is 420 mm of Hg. And also assume the ideal gas. That means ideal behavior for the gas. Okay, so we have given the vapor pressure for at this temperature for the benzene and octane differently, and we have given the benzene to octane molar ratio, which is 3:2. You have to tell the vapor pressure of the solution. Okay, this question has been in the NEET examination in the 2021, and the options given are 350 mm of Hg, 160 mm of Hg, 168 mm of Hg, or 336 mm of Hg. You have some time, go through it and then try to solve it, and then we will see that what will be the correct answer. Okay, let's see. So for this given question, the correct answer is option D, 336 mm of Hg. Now let's solve it, that how this will be the answer. So first of all, what are the given quantities we have? Okay, so the given thing is that we have a benzene to octane molar ratio given, right? Molar ratio means number of moles. So number of moles of benzene to the number of moles of octane is given as 3:2, right? And you can also say from this given molar ratio that the total number of moles present in our solution will be 5. 3 plus 2, 5, right? And the mole fraction for benzene, because we are talking about, so first of all we have to relate this question. We have here mentioned that it is from section 1.4, okay, but in the examination this kind of information will not be given. You have to relate the question with the formulas, with the concept you have studied. So in the question we are talking about vapor pressure, and in the vapor pressure we majorly talk about the mole fraction, and also the molar ratio is given. Okay, so the first task is to convert this molar ratio and to get the in the fraction and to get the mole fraction of the benzene and octane. Okay, so the molar ratio is given as 3:2 of benzene to octane. So the benzene mole fraction will be the number of mole of benzene, that is 3, divided by the total moles, which is 3 plus 2 as 5. Now the number of the mole fraction of octane will be number of moles of octane, which is 2, divided by the total moles, which is 5. Okay, so these are the mole fractions for benzene and octane respectively. Now the total vapor pressure of the solution will be equals to the sum of vapor pressure of each component, right? And the one component vapor pressure will be equals to the product of its mole fraction and its vapor pressure of pure form, right? So we just have simplified this equation, and this is the NCRT formula, numbered as marked as 1.14 in the NCRT textbook in solutions chapter. Okay, so the pressures of the solution is given as P naught of benzene, that is the vapor pressure of pure benzene, multiplied by the mole fraction of benzene, plus the vapor pressure of pure octane multiplied by the mole fraction of octane. Okay, this we have here, right? These two things also we have. Why? Because in the question it is given vapor pressure of benzene is 280 mm of Hg and octane is 420 mm of Hg at 45 degree Celsius. Now we just simply put the values. So 280, which is for P naught benzene, multiply by 3 by 5 mole fraction of benzene, plus 420 P naught of octane, multiply by the mole fraction of octane 2 by 5. Okay, and you have to solve these multiplication terms and then you have to add them. So it will be 168 and this will be 168. Okay, both are 168. When you add them together, they will be 336 mm of Hg. Okay, so this will be the vapor pressure of solution of benzene and octane. Hence, the correct answer is option D. Okay. Okay, let's move on to our next question. Okay, so this question is again a MCQ question, and we have taken this from NCRT subsection 1.4.1. The question says, which of the following statement about the composition of vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? So we have given that there is a ideal mixture of benzene and toluene in 1:1 molar mixture, and you have to tell that from the given options which statement is correct about the composition of vapor. So assume that the temperature is constant at 25 degrees Celsius, and it is also given that the vapor pressure of data at 25 degrees Celsius for the benzene is 12.8 Kelvin Pascal, and for toluene it is 3.85 kilopascal. Okay, kilopascal. For benzene, vapor pressure is 12.8 kilopascal, for toluene 3.85 kilopascal. So this question has been in the NEET examination in 2016. The options provided are: the vapor will contain a higher percentage of benzene, the vapor will contain a higher percentage of toluene, the vapor will contain equal amount of benzene and toluene, or none of the above. Okay. So in this question, we have already mentioned the vapor, about the composition of vapor for the benzene and toluene, and you have to compare them and then you have to tell the correct answer. Okay. We have also given the vapor pressures for benzene and toluene. So over this, apply the concept you have learned in this chapter and the formulas. Okay, so you have some time, go through this question and then we will see that which option is the correct answer. Okay, let's see. So for this given question, the correct answer is option A, the vapor will contain a higher percentage of benzene. So how we are saying that? So let's first of all solve this question. So let us consider that A is benzene and B is toluene. It will be easier for writing the solution, right? So in the 1:1 molar mixture of A and B, because A is benzene and B is toluene. Now, this we have already done, but let's again rewind that we have given the 1:1 molar mixture, molar ratio of the benzene and toluene, which we supposed or which we consider as A and B. So mole fraction will be the number of moles of A divided by the total moles. So for the benzene, for A, the number of mole is 1 and divided by total moles is 1 plus 1, which is 2. And similarly, the mole fraction for B, which is toluene, is number of mole of toluene 1 divided by total moles, which is 2. So these are the mole fractions for benzene and toluene. Now, the total pressure of the solution will be P is equals to P naught A chi A plus P naught B chi B. Okay. This is the NCRT formula marked as 1.14 in the NCRT textbook of the solutions chapter. And basically, the total pressure of the solution is the sum of the vapor pressure of its component, right? And the vapor pressure of a component is equals to the product of the vapor pressure of pure component and the mole fraction of the component. Okay, so we just simplified this, and the P will be P naught A chi A plus P naught B chi B. Now we have P naught A as 12.8 given for the benzene. We have P naught B as 3.85 given for the toluene. We just put that, and chi A chi B we just find out. So 1 by 2, 1 by 2. Now you have to solve this and then add into this. So the pressure or the total pressure of the solution is coming out as 8.325 kilopascal. Now, the mole fraction of the each component in vapor phase. Okay, this the mole fraction or the vapor pressure we just calculated is in the solution in the liquid form. Now, if you find out the mole fraction for the each component in vapor phase, what the calculation will be? So Ya, which is the mole fraction for the A, that is benzene, will be equals to P naught A, that means the vapor pressure of pure A times the mole fraction of A divided by the total pressure of the solution. Okay, so this is the equation or the NCRT formula marked as 1.17 in our textbook in solutions chapter. Now simply we just put the values which we already derived or which we have given in the question. So P naught A is given as 12.8 kilopascal, so 12.8. Okay, so here kilopascal is given. Okay, kilopascal, that means pascal into 10 to the power 3, right? But we don't have to worry because all the units, there is no conversion of unit takes place in the question, and also in the options no other kind of unit is also given, so there is no need to worry about. So we just calculate all the terms in the kilopascal only. Okay, so here we take 12.8 times chi A is 1 by 2, so 1 by 2 upon P, total pressure is just 8.325 we derived, so 8.325. Okay, you have to solve this fraction for the mole fraction of benzene in vapor phase, and it is coming out as 0.768. So this is the mole fraction of benzene in the vapor phase. Now the YB, that means the mole fraction of the B, which is toluene, will be 1 minus Ya. Due to the relation, you know that in a solution, the sum of the mole fractions of the component will be equals to 1. Okay, so if you have a two component A and B, their mole fraction sum will be equals to 1. If you just find out the value of Ya, you can derive the Yb value from this equation, which will be equals to 1 minus Ya. We take this Ya here. Okay, so Ya value, which is 0.768, you put here. So YB is equals to 1 minus 0.768, and 1 minus 0.768 will be 0.232. So this is the value of YB. That means the mole fraction of B, that is toluene, in vapor phase. Okay. So in the liquid phase, we are denoting the mole fraction as chi, and the vapor phase we are denoting as Y. You can call it, maybe it has some other name, but here we are calling it as Y. Now the vapor phase is richer in the benzene compared to the liquid phase, right? So in the liquid phase, we have benzene as mole fraction as 1/2, and the toluene is also the 1/2. But here, when you calculated the mole fraction of the each component, benzene and toluene, in the vapor phase, the benzene compared to the toluene is larger, right? Because the benzene is more volatile, it has higher vapor pressure. So the vapor will contain higher percentage of benzene. Okay. And the benzene has higher vapor pressure, thus in the 1:1 mixture for the benzene and toluene, the vapor will contain the higher percentage of benzene. Hence, the correct statement which is correct or which is defining the question is option A, is given in option A. Okay, this is the question that you have to identify the statement which is correct. So the statement correct is that the vapor will contain higher percentage of benzene. How we calculate? By just seeing the mole fractions of benzene and toluene as per the given information in our question. Okay. Okay, let's move on to the next one. Okay, so this is a MCQ question, and we have taken this from NCERT section 1.6. The question says that at 100 degrees Celsius temperature, the vapor pressure of a solution of 6.5 gram of a solute in 100 gram of water is 732 mm. If the Kb is 0.52, the boiling point of the solution will be. So we have given some amounts that at this particular temperature, 100 degrees Celsius, the vapor pressure is given for a solution which is for a solution in which the solute is 6.5 gram, the solvent is 100 gram, and the vapor pressure of the solution is 732 mm. Kb value is also given, which is 0.52. You have to tell the boiling point of the solution. So this question has been in the NEET examination in 2016, and the four options given are 101 degrees Celsius, 100 degrees Celsius, 102 degrees Celsius, or 103 degrees Celsius. Okay, so you have some time, go through it, try to solve it, and then we will see that what will be the correct answer for this question. Okay, so let's see. So for this given question, the correct answer is option A, which is 101 degree Celsius. Okay. So here also one thing to consider, or one thing to think about, is that the options given are in units, which is degree Celsius. Okay. Anyway, the question has also the temperature in degree Celsius, so no need to worry. Now, relative lowering of vapor pressure, if you write, it will be given by P naught minus Ps upon P naught, which is equals to N by N. And you can also write it as W1 by M1 times M2 by W2. Now, this is the equation or the NCERT formula marked as 1.26 and 1.28 in our NCERT textbook in the solutions chapter. Okay, P naught is the vapor pressure of pure component, and Ps is the vapor pressure of the solution. And W1 is weight of the solute, W2 is the weight of solvent, Similarly, M1 will be the mass of solute and M2 will be the mass of solvent. Now at the 100 degrees Celsius, which is the given temperature for in our question. So at 100 degrees Celsius, the P naught is 760 mm. It is already, you know about it. Okay, so at 100 degrees Celsius, the P naught will consider you will consider be 760 mm, and the total vapor pressure for the solution you will take as 732 mm. Okay, which is given in the question. Now, simply you put the value for P naught and the PS in this formula. 760 minus 732 divided by the 760 equals to the W1, which is 6.5, which is the weight of solute, multiply by 18, which is the mass of solvent, which solvent here is water. So water molar mass is 18. Okay, so H2O 2 times 1 plus 8 times 2 is 16. So 16 plus 2 will be 18. Right? So 6.5 times 18 divided by the M1, which is the mass of the solute. Solute here is, okay, it has no name. We just use it as solute. Okay, so mass of solute multiply by 100 because the weight of solvent is given as 100 gram water weight. Okay, here in this whole equation, the only variable thing is M1. So you have to find this. So M1 from this equation, after solving this equation, M1 is coming out as 31.75 gram per moles. Okay, so this is the mass of solute. Now we know that delta Tb, that elevation in the boiling point, is equals to M times Kb. M here is molality and Kb is a constant. And this is a equation or NCRT formula marked as 1.30 in the NCRT textbook in solutions chapter. So M and Kb, so Kb value is already given, right? 0.52. M1 you just have find out. So we use this in calculating the M, molality. So molality will be the number of moles divided by the weight of solvent in the kgs. Okay, so number of moles will be the given mass upon the molar mass. And so given mass upon molar mass will be numerator. Okay, if you write here, M will be the number of moles divided by the weight of solvent in kg. Right? Number of moles will be the given mass. Okay, sorry. The given mass upon the molar mass divided by the weight of solvent in kg. Again, I write like this. Okay. Now this molar mass will come here in the denominator as like this. So weight given mass divided by the molar mass, and the weight in the kg is already here W2, but it is given in the grams. Okay, so we for the conversion to kgs, we just divide it by the 1000. So we divide it by 1000. This 1000 will go in the numerator. Okay, and multiply by kb. Right? So W1 by M1 times 1000 by W2 times kb. So del TB will be 0.52 multiply by 6.5 multiply by 1000. Okay, 1000 for the unit conversion, 6.5 we have taken the weight of solute, 0.52 we have taken the kb value divided by 31.75, which we just calculated as M1, multiply by 100, which is the weight of solvent. Okay, when you solve this, the delta TB will be 1.06 degrees Celsius. Okay, and delta T, this is the value of delta TB. Delta is representing the change of boiling point. Okay, change in the boiling point. So therefore the boiling point of solution will be 100 degrees Celsius plus this extra change of temperature, which is 1.06 degrees Celsius, and it will count to approximate 101 degree Celsius. Okay, so this will be the elevation in the boiling point. Yeah, elevation in the boiling point for the solution, which is 101 degree Celsius. Okay, so the elevation of boiling point is basically this much of quantity or this much of temperature, which is 1.06 degrees Celsius, which is the elevation in the boiling point. Okay, change of the boiling point you observe, which is 1.06 degrees Celsius. Now, the boiling point of solution will be the 100 plus this elevation of boiling point, which is 101 degree Celsius, because you have to find out the boiling point of solution. Okay, and hence our correct answer is option A, which is 101 degree Celsius. Okay. Okay. Thank you so much.